Trees need pretty much three things to grow. They need sun, water, and nutrients. The leaves need sun to take carbon from the atmosphere and create their cell structure. They need water to keep the functions going, and they need the nutrients from the soil to aid in processes and be part of the building of the tree. You look at these trees here, and they have a lot of green leaves, but up top they have some dead branches. That doesn't mean the tree is dying. That just means at some point in the last years, everything didn't match up correctly. They didn't have enough of everything, so some of the branches had to die. These trees might live for another 50 years, but those branches are dead. So that's a mechanism that allowed trees to grow a long time. They don't need the exact same conditions every year. They can adjust and adapt to different situations. So when you go out in the forest, these trees are obviously in front of a building and they have their own issues with pavement and roots and all that. But out in the forest, you also have competition between trees. So every tree is trying to grow as big as it can and do as well as it can. But when you have trees close together, if there are too many trees, that can also be a factor in how big they can grow and how healthy they can be. Hello, my name's Joe Beeson. I'm a master's student here at the College of Forest Resources and Environmental Science here at Michigan Tech. I'm doing a master's. I'm in my second year working with Dr. Tara Ball, and we are investigating maple health in the region. If you've been to the Northeast United States, or Michigan, in our case where we are right now, the Upper Peninsula of Michigan, especially in the fall, you'll notice incredible colors across the landscape, mainly due to sugar maple. That's the tree we're standing under here. It's the predominant species in our forests, and it's beautiful. It produces sap for maple syrup, and it's an important lumber source in our economy. And we're trying to protect and understand the growth better in order to make long-term plans and help protect our forests and ensure that we have healthy, ecologically sound, and productive forests going forward. All right, this is where I do my work. With this study in general, there was thousands of hours of field work, but that's all done. That's all been done in the previous work. So here's where we sit down and spend a lot of time on this computer and look for correlations and try to figure out things that are happening, and do a bunch of work on our GIS program, but also do a ton of stats and try to get to the bottom of how things are working. So it's important to know that maple dieback is what we measure. That's what % of the tree is dead. Maple decline is more of an epidemic or a systematic across the region. So we're not considered to be in a maple decline, but we do measure dieback. You're actually losing like a lot of wood, a lot of resources, a lot of carbon across the environment. This is the national map published by the Forest Service. It shows basically the area that sugar maple exists on our landscape, and then highlights areas in pink and then darker red that are higher at risk for this maple decline. And what we do is we want to improve this map. We want to say, is it accurate? Is it actually showing us areas that have decline? And so we take this map and we put it into our GIS program, and we're able to zoom in and see not just big patches, but look smaller at individual pixels. Each one of these pixels is 240 meters, 5 hectares, or about 1 acres. And that's telling us in this area, we think there's a higher risk of maple having adverse health. So then we make this whole plot network of 120 plots, mainly right in our Keweenaw region, but we have a couple in Wisconsin, a couple east of Marquette, and there's even a couple up here in Minnesota. So right now I have the background is this map in finer scale, and then overlaid are our plots, and we have different plots that have different amounts of measured dieback. We can go in and connect the dots and see, does decline, the risk map, match what we're seeing? Are they actually predicting which areas will have worse health for the trees? And the answer is no. We're not. If we take their risk map and look at our plots, there's almost no correlation between them. And so that's where we're saying, what is actually happening? Why can't we predict? And part of it is the scale. This map is not specifically designed to tell you on a per plot, on a small stand area, exactly what's happening. But we want it to be better. We want to improve this so that in the future, we're able to say, we know this area has potential for bad health because the soil is poor and it's on a south-facing slope or a north-facing slope. And we can attempt to improve this understanding using this huge data set and going in, taking different variables that are publicly available to download, like the soil survey data and our elevation maps, different vegetation covers, and add those to a model to attempt to improve how well we can predict that.